Okay, you go from here. You can play music. I'll show you. I don't think you'll be able to hear it, but I'll show you. I don't know, the mic is maybe right here on the bottom of the phone. I don't know if it's legible to hear. But okay, so anyways, you can hear it. So you turn the back, hit back again, doesn't do anything. Go over 4 paces, go to music. I mean, you could score it all, you write it all down. I'll just tell you how to do it. This is a MSO file, so you click it, stops it all. So you know what an MSO file is. It's a designated file for containers, for outfits, for food consumption, correlation, and composition. So basically, this device is meant for something else, right? So an MSO file is now what? Now it counts fit. Basically, since it shakes, basically it has less RAM and memory in it. So it's basically grass-fed or fed. So basically, the mp3 player now registers food in this. You know why it registers food? This is 1C, it's one container. So they program this device right, is it's supposed to be one PC. You know what one PC is? One PC is good for one RAM, one PC. That's like a tree array, correlation and container. Okay, what does one PC go with? One PC goes with 11C. 11C, what's that? Well, that's the container that holds and seals the one PC. It's to save memory, RAM, and loss of data. And let me finish. So that equals out to 2 power outfits per direct correlation. That's the link or voltage standard. It's like a 9 volt plus any additional current. That's amount of current, basically. So that means you can have 2 charted signals in here, and that's why this one has an SD card on it. But we look at it as a 13C signal. So the container has an empty slot with a 13C signal. What is a 13C signal? Is it just a chart beyond this cable right here? Well, technically you might think that, but yeah, yet again, it's not. It's meant for an unknown RAM, signal and technical system. So that's basically what they call it. They call it the air conditioner of the unit. So what does that do? That bounces any Bluetooth signal, BM1 signal, BMR1 signal, BMR signal, and that's all having to do with a cluster of technologies and algorithms that have to do with Bluetooth technologies. So that's 1PG. 1PG is the signal that burns the electricity in the unit, and it sends the signal to the 1C, right? This is 1C, and then it disintegrates it. So the 1PG, 1C signal, and then what else do we have? We have the 1P signal, right? What does the 1P signal do? Technically, it jams, it correlates, and it directs the composite, and the big F, which is controls it. It deletes it. It makes it null. So what does that do? It stabilizes it. Why does it stabilize it? Because it's a unit by itself. It basically illustrates anything by filtering it with mineral, right? Glass. What do you need to do and balance that out? You need a constant, right? You need a constant signal to do that. And that's where the memory loss comes from. So basically the memory loss is the composite of the positive and negative signal. It's not grounded. So basically, why isn't it grounded? Because they don't have a 1PG signal. What is a 1PG signal? Unlocks the MP3 player, turns it on, and you know what else it does? It counts it. So I'm going to set it right now that it counts it. So 1PG, and you'll learn this from a bunch of people that I came up with this concept, right? Well, it's really young, real young. So if you take, it's a managerial account. If you take one signal right here, you have 0.1, right? This one used to be 25. You have 0.25 kernel server. That's like a basic signal server signal. You know why they have that? Because it's what can be in an LG signal. That's something that can fit in a cup, basically. So that cup basically illustrates the signal, right? And we don't want to go on because you parse the information. You set the data and then you scripted it. Because I can hear it in the MP3 bar, right? No, I cannot hear it in the MP3 bar. I can hear it in the clay, because it's made of clay. So what the 1PG signal does is turns the rotor on, turns it off, and illustrates an amperage per current, per turn. What does that do? It forecasts the device, basically. So it slows down any horizons or bumps in the signal processor and server that this device is communicating with. That opens the window, device array, and the signal amperage, and it jams it. So what does that do? It plays a 1 PG signal. Right? It sends the signal back to the horizon. What does that do? It makes it hot, basically. It makes it scripted, which is, 1 PG signal. Basically, it turns it off. It takes that signal, turns the amperage, and makes it higher. So basically, that's like that's like a signal with a cover on it. So like the cover is like an array, right? Cover is like it could be a script, right? But it's not always a script, and it's definitely a container, right? So those scripts and arrays and containers, they all bundle together in batches, right? Those roots are basically batches, right? In someone's mind, at least. And then the two chambers of the cylindrical signal, which is the wire, right? In this case, send the signal, and it sends into arrays, and then DSMRB, so like a database. Basically, it's like a simplified database that sends these signals with loops in them, right? Like a concrete loop, like a brick, like you have set, you set a brick, why they have that, that's for gardening, right? So basically, you set those signals, you set that, roots, basically, and then you set it, to an array, right? And that function plays and plays and plays, but it spindles, spits, and it lineates, basically. So basically, that's where the 0.1, 0.25 concept come in. So the lower the concept, the lower the ratio. The ratio stays significant at a factor of variance. So that variance is ohm over watt divided by 2 split. So a lot of people get the question on what 2 split is. 2 split is, plain and simple, or it's concrete and what? Compost or compact or communication style comp. So that means it's a deposit. The deposit basically sends the signal, and it sends it into arrays, into variances. So variances are like kind of cylindrical blocks. Say it's like the way your eyes work. You can see, you can't see. It displays the image in ohms and watts. They don't get together, but they vibrate basically on a plane window, and they kind of circulate, like they kind of go back and forth. But they look linear almost. They're patterns. So basically, that's the MPG of the function. The MPG takes the signal, crosses that output, and the variance kind of continues basically. And that ohm or watts in that case, because it's transferred, turns into an MPG. And firstly, it wasn't MPG. Now it is a defined MPG. And you know why it's an MPG? Because it wasn't a material good before. The computer didn't recognize the signal because it was made out of something like wood. Or what else is better than wood that is just like wood? Seashells. Shells are just like wood. Why not metal? Because metal isn't a composite of organic material. Organic material is like a hot thing. That's like metal, like that's been defined, right? That's like metal that's hot, that's red, that has a characteristic that you can send a signal or array into. That's what makes the variance loop go and sign as a variable. So I'll get to it right now. The variable basically signs itself as a divisional function. That means it steps up and steps down at any process at any time. That's the breathing room of the system. That's how you counterclockwise, and it keeps on going and going and going and going until there's no more speed. That's how you slow it down to half the rate. Not every system is good. It's like a 3D model system, basically. That's how it works. But again, it works with that MPG, the variance outputs, there's ohms, watts, that system array, and it turns it and defines it. It's like looking through a looking glass, basically. Now listen, that MPG goes through an output, basically, which is defined. That defined output is just squeezing it together into a star, basically, like an asterisk, and then pushing it through. It gets defined, it becomes the output, it goes to the RAM, it goes to the CPU, it follows the array, the output, and the demeanor of the device. And what is the demeanor? The demeanor is the quality control. It's the container, it's the variance, the output, the control of the variance and the output, basically, the MPG. So basically, the divisional line of the variance basically now enters a direct line of currents, a current basically. And that array basically comes into function play. That's when the FC and the forecasting basically comes together, and they meet and they separate, come apart, and then go back together again. But in a simple order, they follow a defined path, basically. They go from 0.25, but they count up to, or from 0.1 and go up and go down. But the significant speed of the processor has to count up to 0.1 without the mathematics in the chip. So basically it takes the RAM, it counts the steps in the process, and then it determines the signal. And how does it do that? Because all the signal is now defined and it's looping around in a circle, basically. And it's going round and round and round and round and round. And why does it go round? And how does the information store in the magnet? That doesn't even make sense. It goes to the MPG. So the MPG is color coded. It basically takes that script. It's now an MPG again, like a MP3, but an MPG, right? It's the file before that. It's coded two separate channels, basically. It's two currents, basically. That's what takes it to MPG and then MPG2. So that RAM is now settled at a factor of RPM per minute, right? And that's 5, right? For most signals, it's a channel or volts current, and that's about 5. And that's stacking, maybe hundreds to 200, BSCs per minute. And that's basically, how you would put it, right? You would take metal and you would stack it to 200 quadrants per second per stack, and that's a volt per RAM, right? That's like glass, basically. You can't go faster than a molecular weight, right? You can't go faster than a model system, or what you might consider weighing something like silicone or sand, or something like that, like organic material, right? And again, why is it organic material? Because this one is mixed. It's an MPG plus a factor of 1 plus 5, a variance that keeps on looping on a E prime, basically. And again, that's the breathing room of the system. So that's basically what charts, all the direct current, basically. That's the outflow, and the input of the system. And that takes that MPG, and again, it takes that organic material, such as like a seashell, and it counts it this time. It settles the stacks on each other, and it basically says, well, this is the significant factor in the system. It takes that MPG once again, and you can go MPG all day, but it's basically 3 arrays, basically the set, array, and function. Again, it's not a perfect system, but it does say those separate systems work on a tree, basically, and the amperage, watt, that volt, that current, and that direct output, basically. Turn that flow and flip the signal up, basically. And what that does, it turns the MPG on. It settles one signal, one array, one current, one function, and one difference of input and output per variance. And it takes that system and it plays the signal in your ear. So basically, it's a cross-channel, 2 wide signal that basically takes that average amperage and it takes that variance output and it settles it once together into a plane or signal that basically vibrates. And that's basically like a refined or expanded piece of tinfoil, on a loop, on a chain that takes that signal, basically, of amperage, or what you might consider average or volts, right? Because it's kind of slang for volt. You take that volt and it plays a bunch of numbers, basically, binary, basically, pushes the signal out, right? It's basically like widening the gap again. Basically, it's defining that space and pushing all of the information through something. Settled, basically, it's on a circuit, it's on a CPU plane. And it pushes it out and it goes up the cable, right? And it pushes it out in one signal. That's where the RAM comes in, it plays a loop. And in this case, it's one MPG. And it takes that RAM, the input, the output, the flow, and the MPG plays that signal into a loop. Basically, it sets it, cuts it in half, and plays it. It just basically forces it up into the other head. So the MPG is now rooted, and it's sorted, basically. So you take that signal, and it's now average inputs and watts, basically, and ohm now. And it takes that MPG, and it takes that average, and makes the application. The application basically becomes like a divisional line, that function, purpose, array, that protocol, that PM1 signal. Now it plays an array, it plays a loop, but it's now acrylic, so it's now vibrating. The MPG is now a devised charter between white and red. And what is the difference between organic and like something that's white? Red is organic. White is like the MPG. White is now been defined as a settled signal in the RAM. It's the purpose of quadrilateral functions in programming. So basically, that's sparse programming. That's when I take an MPG again. And you can say MPG all the time, right? It's like saying RAM. It's like saying dual systems. It's like saying two technical toolkits, basically. That's MPG, that's divisional sign, that's the function of settled versus aerodynamic. So that's basically a signal that is cross-threaded, cross-determined, and that's settled. So that's a system built. So that's a MPRG, basically, that settles signals like on two tree arrays, and their functions are settled but split and different. So those collateral systems are like fruits from vegetables or fruits from plants that are meant for like crossbreeding, basically. But there's one specific one because it grows, in a charted like outlook or outlet, which is like basically saying it's like not design, it's a technical thing. It's a plant array, basically. It takes the weeds basically, and it forces them up, and they turn. So it's basically like amplifying all the signals up, and it's like steepening the outcome, basically. It's like saying like you're in like a valley, right? There's a hill on your house, and it's filling all the signals up until you can see the signal on the top, and it floats all the way up. So right, it grabs the signal this time. And that's basically what MPG does, right? Fills it up, throws it out, and then it kind of determines the output through other means. The MPT, like it kind of designs, it looks at all the flaws basically through like kind of metallic kind of overits, basically. It like counts it through like particle like assimilation, right? So, you go on and on and on and on and on about this. But the food design in the MP3 player, basically. So the signal takes the MPT, MPE, right? And they're different things, right? So like you could say, there's like a T cell in like human genomics, basically. It counts the average watt and amp, right? But for a person. So it's like roses, buds, and thorns. You take that MPT, the MPE, and it grows like a root, and it says it's a system variance or output or MPG, right? And it takes that MPT, and now it takes little subsystems, and then it designs them into a flow, basically a stack, an array, a function, and then kind of a definition. And it again defines it. So the difference between the MPG and MPT, one defines and one is a definition. And that's like saying a description versus to describe, basically. And basically, the two don't work together. You can't have them on the same signal. MPG, MPT, they can't. They have been designed to work in MPT and MPG, surroundings, basically. So it's really summed up in an array. And again, it's like C++ versus like C, right? So it's that MPT, and it creates a like E signal, right? E prime. And then it takes that function to the MPT, and then it creates a outflow, outlook, and out ROM. So basically, it takes a ROM file, or a outer proximity signal. Basically, it takes like the modular kind of design, the weight of the system. It takes the MPT, and then it devises like a RAM output and RAM. So it's like an E prime, or it's like E signal. So the stacks and flows now is turned into EPTs. These EPTs like now design, functions, arrays, and then quality things you can see. Basically, those are STUs, right? STUVs files, right? And then basically the work. But again, all of this is divisional without the divisional point, right? So I say divisional like it's a function of an array, right? So that 0.1 signal is now, a signal that's growing, right? It's MPT, MPG, and it's surrounding signals, which are RAM, ovariance, mechanical illustration and flaw. So that's MPT, anything that's, organic and inorganic. I mean, again, it goes on all day. So there's 1 through about 10 ohms or watts or amps in this setting, right? But they don't count and stack at the same time. They all count different. They all depend on each other. And it was one outlook, one outflow, and one design, basically. So the 1 PT, 1 MPG, and then the ST, and then the STE files come into play. And what are all these? These are all 3,000 to 5,000 amp watts. And you're like, well, how does an amp watt get on there? It's designed to be MPT, MPG again. It's a 1 PE signal, right? That's what basically it does. It basically grounds the signal basically through the top pane of the signal. Well, how do you do all that? And like, you can't do that because it doesn't do that. It will just shatter. It's like a Rupert's droplet. The more glass or mineral you have, you throw it, or you want to mess with it, you want to like define it somehow, it just shatters. And that's what happens. They just break. They just fall apart. And it doesn't take much. It just takes a crack of the system, basically. So that system now becomes this red plane. It was already red before. It was telling the system it couldn't go anywhere. Right? It's organic. And now it's taking it, flicking it, it cracks it, and then now the root is exposed. So that's the MPG. That's the MP1 file. And that's the MP1 file. Like, why did they decide it like a MP1 file? That's how they made it. That's how microscopic technology worked back in the day. So that's MPST. That's wood frames, computers, and how they made MSPT or MPTS. There's a definition between the roots and the cause of the functions between two definitions and two variances and then two arrays. So that basically there is a difference between signal and output and process speed versus like something like a function array, and that's a setting in like something like a programming like BASIC, right? Those MPTs are now like an MPS signal, and that the MPS is like now a signal versus an array and function, and that defines an organic material in the computing device as MPT. So that basically any user function now is designed to illustrate the inflow and output of electricity. So now what do you get? You get no definition. It just defines all the the kernels basically again. So basically, once that's settled, and I won't get into this one, but it's basically the logistics exchange training parts, the part that defines every system, and it trains the model of the computer basically. So you can take your thumb on the model and see if it's up to date or not, and you could fix it easily. You could boot up memory that's not on there, or you could see something that maybe didn't happen. Or someone didn't see. You could, or get files from the device that had it on there, or look into a mic channel. Basically, a mic channel kind of works similar. It's working organic versus MST or MPV, or MPE. So those are like signals, arrays, functions, and MSPT. So it's like RFID technology. That's how like management works. That's how things are printed. That's how computer systems work. That's how things flow. That's how a router on a Wi-Fi works. That's how a motor works on a machine. So basically MPST, so they can be reversed, they can be crossed, they can be cross-faded, and those are all organic channels basically in a realm of MPST and MPT, MST as well. So that basically hardens the system, and it makes it a root chain cause function in actuality of the system to turn on, turn off, and function. So that's tricking the system into thinking it's organic now. The MPST now engrows, lowers its function, and then it hardens the system, so that changes the color. So that organic material now changes to a different color, and it takes that MPST and it basically erases the data. Basically, MPST there is still there. Those are the leaves of the arrays. Basically, the MPSTs work in different function and matter, and then array now works as a circular output and input. And why does it work like that? Because the RAM stores it. Or so suppose the RAM stores it, is stored on the flash basically. The MST is now a E' or MPE file. That's how they design the thing. It's called the Big Fat Cat, and it takes the MPST signal or MPC signal, and sometimes it's different between Europe and the United States, right, or Emirates. And the MPT signal is now defined in charters. So that depends on what function array and setting you have there. We call cause, effect, or system input and output, the MPST. So basically that system is now round or circular in its dimension. It's an MSPT, and you're like, why do I need this to define a function and put a model or a system or MPST file on it? And you say, well, that's because the output and outflow don't work, and the E' don't work either. EI is a technical deliverable basically. That's to deliver MPST signals, that's flawed signals, and their channel, and that's MSPTs, that's roots, arrays, and functions that don't count as matter. Any organic material that doesn't count, the MPST signal now is a variance output basically. That channel is now curved, domed, and now echoes basically. That MPST actually flows the input and output of the device basically, and it devises your system input and output, and that takes that data and flows it like a beehive basically. That MPG now laterally inputs that signal and turns it into an MPT, and it flows variance in current. So basically, that's like we're very strong organic material now, and it's that MPST that takes that flow and converts it into a channel, which is converting the signal of inorganic into like a material that you can read in between and stuff like that. So basically, that's how you get from 0.1 to 0.25. But somewhere in there, there's variance, outflow, out control, system arrays, functions, and technical output, input, limits, functions, arrays, min, max, obviously, defined functions, set functions, and there's defined, functions, arrays, and all those things, right? But they don't do that always. They put it as an MPT, MPE, MPEI file, and then they cross it with an MPT file, just like this EI pattern. MPT file, and then it crosses the array function channel, and the MPV flows through a system channel converter through an MPT, and that file functions or goes through a function that takes that MPT file, curves the function, and turns it into a technical signal, which is an MPT signal again. It crosses the array channel and the MPT again. And that MPT channel function turns it into two separate routes that can spread two channels, two arrays, and two functions at the same time. That MPT signal takes that channel, takes that route, and then turns it into a CR signal. So that CR signal turns that loop, reverses the signal, turns the MPT on the other end, and then throws the signal all the way through it once again. And the MPT signal flows through that signal, and it makes a lot of noise, and it causes disturbances in the headphones, obviously. The MPT signal can pick up routes from other MP3 players or other MPT signals out in the flow. So it's like data, arrays, functions, flows, sets, arrays, malfunctions, and MPT signals. Not EI signals, but MRI signals. So those are MPTs, EMIs, and MS1 signals, but those vibrate. So those MS1 signals are organic channels that are MPT3 signals or MPT3 EI signals, which isn't really defined. It's like a fence, basically, that takes an MPT signal, turns it into a hard codon or codon, basically like a molecular output. So they say, and the MPT signal flows to the output, input, and then goes to the MPT signal, the fat cat again. And the MPTEI signal goes to that flow and turns that converter into an MPT signal and flattens the signal and turns that rate and slows it down, basically. The MPT signal turns that route, that turns that flow, and takes that MPT signal once again, flows into the direction, and then turns that MPT signal into one signal, basically. Why did it go through all of these signals through root, array, function, what some might consider the mental state of how it goes, or the 0.1, basically, that's the corruption between the 1 and the 0.1, the fat cat again. The MPT signal disagrees with that fat cat, that takes that MPT signal, turns that array and function and that protocol into MPT signal. Once again, it keeps on cross-checking it all over and over again, like something isn't right, like the seashells aren't like conductive. But they were one time they were conductive. The MPT signal takes that array, that function, and turns it into clay, right? The MPT signal turns it into 1V, or the red organic signal. It takes that MPT signal. Once again, it turns that array, and it's like crossing the loop. And again, if you're functioning right, it's a virtual machine. It's a property. It keeps on going to MPT signal until it reaches a certain limit, and that limit is an MPT signal 1. So that's 1. Basically, just we were talking about 1. So basically, that's a chartered input, output, and flow. So basically, that's like a neutralizer, a wire that doesn't cross-chain, cross-connect, or DP, in other words. So DBT basically is logistic input and output. And like, why doesn't it work? Why doesn't it work? This is not in the right input and output. The MPT needs to be cross-inputted into an MPT file once converted into one MP1 file. And why didn't they do that? Because it's crossed into two different converters, one MPT file, right? One MPT, one file. And basically, they cross the chain, turn the network on, and then it goes into one MPT file again. So like, why would it do that? And that's so you can select any amount of information into any protocol at any time. This device has that function built into it. Why? Because it's in Netgear. It's in one MPT file itself. That's how they were designed. That's how they designed two arrays, two functions, and two settlements at the same time. That's one MPT, and that cross-chains the effect. So you're like, why does it work like that? And that's like, because it's echoed. It's an echoed chamber. That's like how a Q or a qual bulb would work, like something hypothetical, or like a flash ball, basically. And they might call it a flash ball, right? Or a one MPT, But it basically, curves that overture and takes that one MPT and flows the indirect input and that outflow or output and flows it together. So that's it, one MPT, that signal turns into a PT signal, which is one array, one function, one virtual machine, right? You add that all up, that one MPT, it's now like porcelain basically. That's how they're building it. The one MPT is one E signal, right? Turns that channel, that output, that outflow, that input, right? It turns into one MPT signal once again. That outflow turns into one MPT signal, and that MPT signal turns into a flow of data, channel, array, function, and then the one MPT again. And then you're like, why didn't it work? It's not supposed to work. It outflows, outcasts, and divides the system into a direct input outflow. So that's so it can chamber basically. It can go through the glass. It can check the system like a microwave would. Like it checks the processor in the microwave. All it does is flick it basically. It goes up and then goes down. It's like a metal shell like in a smoke detector. That's how a smoke detector works. The voltage, ohms, out watts, and then the proportional inputs or outcomes. That's the static electricity that's in the device sprayed with like a silicone, starch, resin. So basically it's like porcelain, starch, resin, not clay, MPT. That's like when it was designed, they used to use clay all the time. In the 90s, they did it too for a little while, and wood, but some of it stuck around, some it didn't. And then it basically turned the signals, it turns that 0.25 into an array basically, and that array turns into a function or a subtle kernel because there's more kernels to be counted. There's kernels that are counted and it turns into an array, a function, a motion, definition, a easier going system. The kernel can back up one kernel and it can take the array out, it can take the function out, it can take the circuit, basically re-imprint it. And that's another thing what the MPG file does. It takes that circuit, takes that file, and now it takes the codons, basically, the one MPG signals, the through output. Basically, that's the ones that send the signal into one MP2 signal now. And it takes those arrays and functions and it turns it into DPD2 or something around the sorts of a DB2. And there's different signals for different countries. It's called different things. It's like JavaScript through PHP or like, JavaScript through AppleScript. There are different concepts. There's scripts. They're JS scripts basically, but there's no settled name. It's like 1, 2, 3, right? 1, 2 chambered though. There's arrays and outputs are now flows into two functions. It's like saying like you have 4 stems in a Grammy or like something like a Punnett square, and you add them up, right? Because you can't cancel them out. You never cancel Punnett squares out. You take these arrays, functions, and they spread into MPGs. So it's organic material again. The organic material now closes the loop by bursting the signal. It's like making a plant grow really fast. And then it grows it and it closes, the new one closes, at least the seedling or the bud closes, and then that one MPT signal goes again and it plays that array in output. And that one MPT signal goes, it takes that array, and then it takes that array and it takes it into one MPT signal. Why is the one MPT signal important now that it's counted to 25, right, or 0.25, or the one MPT signal basically takes that array, that function, that closed circuit right now, and then it basically defines it, flips the switch or flips the cover basically. Once again, accidentally or purposely, it turns the power on or off, and then it takes that circuit and then it closes it so it can't be touched anymore. The one MPT file now on the outside of the shell basically turns it on. It's like shells or valence current basically. It's chartered, it's selected, and how those all work with the mapping. So basically you're up to 25 right now, 0.25, and you're wondering how it works now. So it's one MPT signal now. Once again, that signal basically turns the conversion on, that file that converts all of the electricity into power basically. So it takes segmented blocks of energy, curls them up basically, makes them hot. The one MPT file, it turns on, right, settles the system, and then it turns the one MPT, the one MPT file and the one MPT2 file on, meets the system array current flow. And again, the array is the biggest importance there. It's like 1, 2, and 3 basically. Now it's settled basically. It's grown in outflow basically. It picked up a resonance signal in that flow. That stack is now an array function. And you can go on. They just basically define, develop in arrays, constituent signals, and then flows and arrays, and then functions and districts. So why is a district different than divisional? Because it's one MPT signal again. So why does it keep on flowing and going and going, and why doesn't it go? Because it hasn't been settled yet. And why hasn't it been settled yet? Because now on the processor, and it gets very, very, very critical, right? that one MP3 signal is now picking up an outflow, and that outflow is now shaking the device. It's saying it can't accept any more things. It's saying that flow is now not connected to anything. That power isn't doing anything. That flow is not sitting on anything, even though it's playing, right? It's saying it's one MP2 file is now like a thing, right? It's dangling, it's shaking and saying. It's like being in a hurricane. This thing is a computer, right? And that divisional line the function, this works on with any system basically. It's a curl file or Carol file. And it basically, takes that one MP2 root. Now it's rooted. You can see the root because it's like almost, out of the ground. The system has developed this system to, process this flow, right? It's stacked through hundreds microseconds and, flows of input, output, an array, current, and flows in a checksum, basically a checksum, check option, and that one MP2 flow or file basically turns that curl system. It takes that one MP2 file on the other side and districts it, so it slashes it, and you can go on and go and go on and go on. But basically that parallels the line, slows down the critical thinking mass of the computer. Basically, it turns it into one MP3C file. So it basically takes the input outflow, takes that 5 volts, and it turns into an input of 100 volts, basically. Even though the computer doesn't go in there that much, it doesn't take that much energy, it takes that one MP3 file and it turns it into curl systems, and it coats it, and it makes it slower. That volt system now is growing ohm versus volts versus amperage, basically. It's coded, basically. It's coded to design that way. It works that way on the computer. It takes those files and then takes a one MP3 file, make sure the organic signals, cross-fade, cross-channel, whatever you call it, takes it and defines them into one MP2 roots, and those are indexes, basically. It tells you if it's on, off, or set. So basically, those files are like 22 is less than 23 is less than 24. But basically, it coats them. So this is like the big concept. It's like coding them with colors. It's like saying, well, this is the new root, the new array, this is the new jam, this is the new function, this is the new beehive, right? The hive of the function of like throwing 2 charts into one signal. So it's a one MP3 file. It's basically the tripwire, and it's a comparison to a signal that is like a slow-moving metal. Basically, it's like half the atomic weight of like polonium, or polonium. Basically, chemical element 86 in the atomic periodical elements, and that's how the function works. Basically, it inputs everything through signal 42 of the atomic weight, goes to 84 basically, and then it flows that signal up, and it basically takes out one MP2 root. And that's a root, and because it's color coded and everything, it's set, basically. It's set to just flow directly out there. It's all critical before is it works through a loop. So that file would be considered like an E4 file. It hasn't been defined, it's RAM, it's preset, it's root. So it's basically the so, pre, and try of the system. Takes the roots, the files, and the demand array function, signal ovariance, the MPT, the G signal, like the receipt of the transaction of the mechanics of the signal, and that's for every single thing on the root, and then it cuts it in half basically, or MPT, so it lowers it to 84, or 42. Takes that MPT root and then devises a system, charts it around. So no, basically it's moving by itself. It's on a positive signal or chain, and you're like, how did it get to a positive signal or chain? This is on MPT file, basically. So it's like all compassed around, and they're like, what didn't you tell me this before? And I'll tell you now. The MPT file is now a root. It's basically a vessel to keep on, moving the signal up and down. It's like how the signal on a 96 FM radio would work. That's the crossfade channels and loop channels into 2 signals, 2 arrays, and 2 functions at the same time, called an ohm variance root. So basically that's a one MPG signal. Why can't I access that? And like, you can't access it because it's covered in the MPG file. No, it's covered in like one MPT file. It's not accessible because it's not something like people want you to access. It's a one MPT file. It's like a glass bulb. Like, can you buy a lot of critical military glass bulbs, or system glass bulbs? They probably cost some expensive money unless you're a developer. Well, that's basically it. And then it takes that MPT. It takes all that conversion, it flattens the signal if you're going to be very simple. And it's no conversion like MP2, MP3, right? It has a lot of technology. MP2, you're just saying that, and now it's really critical. You can go on for another 40 minutes, right? And again, it's up to that fat cat to turn that one MPT file or one mp2 file now into a mpg file 1, and then turn it into a critical mass. Basically, the critical mass is, when the design learns to, circumvent like one MPT files. So that's basically it sets the dynamic and then array function quality, of the device, one MPG file, and then it circumvents it. So basically, it rotates and vibrates different things different times. The one MPT, like how does it vibrate if it's not vibrating? Is it takes that one MPT file, the one PE file, and the one P1 file, right? And no one says the one MP1 file, and it turns it to array, a variance, and a hood. So that basically a hood is one MPG file, one signal, and it turns it into basically SM1 signal, and then basically takes the input outflow, and then turns it into an array. And you're like, why would it turn it into an array? That's so basically it can be cylindrical. It can input everything as a hard coron, or whatever you want to call it, right? It takes that coron and then it takes it into one MP2 file, and then it basically curls it, curls the file, and it turns into a signal that's one MP2 file. And then basically, what does that do? That basically takes the one MP2 file, and then it makes it divisional. So it cuts it in half, turns the signal into a function, right? Now the function is now one MP2 file. Like, what the fuck is he saying? And he's listening to it. He's telling you the story. And it turns into like what you might consider a 0 day or zero function. Like, what is a zero function now? And that's when the signal flips, basically. That's when the signal can do whatever it wants to do. Like, it basically divides the signal into a purpose root, and that root basically turns into a cast or a casing system. So that's like leaning the system against another file or another invariant. So like, how does it do that? And it's like, because it expands and controls the files, and it takes out one MPT root, and it outcasts the system, and it outflows the system, and turns that one MPT root into two MPT roots by a variance, array, and function, typically done by outcast. So how does it do that? It takes the coron, basically, and I'll just say it right now, and then it basically settles it, like not too deep. It's like in the soft memory of the RAM, basically, and not to get too technical, it's basically like the pumpkin seeds of like the RAM input and output, basically. It grows, but it doesn't grow. It's the one MPT file, and it gets not well defined. Like, they try to define it as much as they can, and it turns into, little ceilings like no one says or can see, but they're just there. So basically, that array, that function, that one MPT file, takes the outcast of all the outcast files and hoods it. So basically, that divisional sign or line of function at 0 day, right, is now functioning. It's crossing and curling. It's leaping. It's going out of bounds. It's flipping over. It's going. It's heading. But what is it doing? It's pointing up north. So it's polar. So it says the current is electrical current versus the volt versus the volume versus the one MPT signal, one P1 signal. There's all cross current at the same time, and they signify roots, arrays, and functions. And you're like, why does it keep on building on the same dynamic and root, an array, and function, and one MP1 file or one MP1G file, right? That's because it's made out of one MPT file. So it's climbing the signal. It's looking for a root that's an array, that's a function, that's one MP1G file again. It's the fat cat again. That's a stratification that says, like, this is bumping now. Like, this one MP1 file is now taking that root, that file extension. It's taking those organic impressions, and it's now implementing those files into one MP1-2 files. And this one MP2-1 files are now dynamic, or crossing the barrier or dynamic of one MP2-1 files. Now, what does that do? That basically signifies that it's a one MP2-1 file. It sets the correspondence between one MP2-1 file and that one MP1 file, and basically turns the corons on again. And what are the corons? The corons are arrays, functions, and divisible input and output, flows and variances. But it's the first channel, it's the remainders of the system, the fat cats that come in, and so to say, fat cats that come in. Every teacher will say it like that because they don't know what they're talking about. The one MP2-1 signal will take the one MP2-1 signal, the two ones, and then it will take those signals and turn those arrays into functions that are MP1-2 signals. Take those and count the array. And how does it do that? Because it takes the array, it takes those functions, it takes the curled steps, it takes the one MP1-2 files, and that's when it gives it access. Basically, the access goes to roots, arrays, functions, variances, not in that order, but the one MP2-1 file will take that file, it'll take the one MP1 file, make an impression of the file. And like, how does it do that? Because it takes that and it flashes it basically. It's like it's painted with something. It's painted with something. Yeah. And one MP2 one file is taken into one MP2 one files twice. And you're like, why does it do that? Is they're pinpoints. They're pinpointed into one MP2 one files. And like, how do they do that? And like, they refine all the metal. And that one MP2 one file basically turns it into an array input and output. And what does that do? And that takes the folder quality, the stack array, and it turns into a folder. And it takes the one MP2 one file and turns it into an array, a function, one MP2 one file. And you're like, how does it do that? It takes you a one, and now you're listening. It takes in a one MP2 one file, and then it cross multiplies. And like, why does it cross multiply? It's like, that's the first step. The first step is to turn the energy off the device to save that energy. That's going through glass. That's looking at data that hasn't been sparse, the neutral input or positive flow, the input, the output, the flow that stacks the array, that curls the variance, and it basically takes that input and output and it separates it. And you're like, how does it separate? I'm like, I don't know that one. The one MP2 one file basically takes the chartered data from the signal, and where's that from? That's from the polarization of Earth, right? That one MP2 one signal is now cross-charted through one P2 one file. So it's like magnesium, alloyed, glass, one MP2 one file. So it's one MP2 file. What does that do? That signifies light, basically. It turns flickering light on, basically. That's the simplest way to put it. Where it charts, magnets, it's like a Hall array sensor, right? Or one MP2 signal, or one MP2 one signal, basically, that cross-codes color, basically. Not every color has a codon, right? Or codar. Basically, that one MP2 one signal is now an array. That array is now a function that's settled. That one MP2 signal is now sets arrays, function and value that have scripted definitions. So scripted definitions are now value inputs and outputs of the array function, outflow and outlook of the device. Just like something like BASIC, that script now is calling the script, and it's taking that one MP2 file, taking that one MPG file and cross-determining the loop so it can now cross-charted cables. That's like, why does it do that? That's so you can read like fiber optic. One MP2 file is now the next array up of the function, right? And so one MP2 file, right? It's one MP2. Why one MP2? Because it has to count the array function shell, basically. The one MP2 file of the one MPE file now turns to the CPT file, the CP1 or CPT1 file, and that's like kind of the color of red. It works in ovalence, sums, functions, min, max, I guess. It turns the array functions into two distributed networks that work together in synthesis. So it's like one system is staking it for something else, one system is saying it's something else, but it says it's two. Those array functions are now lateralized, so they basically climb the system, inputs and outputs. It's like a virtual machine that's able to compost energy, or like play energy. Like it's like the headphone with a virtual system. That one MP2 file or one MPT file now takes that function of flow, settles the stacks. You're like, what happened there? And like that takes it one step further. It takes that one MPG file, makes an argument. It takes that two stacks basically, settles those stacks, and takes the surrounding diameter of the container. It takes that one MPG file, steps it up to one more time. It takes it to numbers now, 1-1. So it's something binary can read. Now you're to the 1-1 part. That 1-1 file now takes two variances, two currents, two functions, two loops, or two plays of a button. So it's like the function input output basically. That's array versus function versus rate basically. That's one MPG. Takes those signals, even though it's converted already now into playing three signals, and it usually plays two signals with the organic versus the compost material. That's the metal composite material that's ovariance. And again, that's the training material. That's the LCT file. That's the file that plays that one MPT file again. You're like, why does it play with a training material right now with a one MPT file? Because it doesn't read RAM through the flash. It doesn't read RAM through FATCAT. It takes that one MPG file, right? It takes it like a backwards Nazi symbol, like not or not have, right? Like it takes it and it says one is not and one is, right? One is the good luck symbol for India or Hindi, and one is not. One's bad. It takes that and it says one is not, one is good. And then it says, how do I define it? And it defines it by one. And so it's like one. So the separation is like one corner edge of the system. It takes that array, that function. Like, what does it do? It takes that one MPT file again. And then you could say organization, right? Instead of one MPT file, but I'll say one MPT file, right? This is array function input, flow, output. Organization is a different scandal or situation or schedule. It's a one MPT file is one PE file per one root versus ovariance versus occasion or organization. That takes one mp3 root, takes that devised signal, that red signal, and it illustrates the other red signals. Like counterclockwise, imposes the signal that takes that one mp3 root and climbs the tree, basically. The one mp3 file is now a organized schedule. So basically, it's that one mp3 root and vibrates it into an array function and root that creates a chain. So it's a training signal. It's taking that one mp3 root, that one PE root, and it's training that signal. Like it's like the clay sediment in the device. Basically, it takes the route and it's taking that fool's move, or what you may consider a fool's move, or the average move, the old move. Basically, that one mp3 root takes that ovariance and then takes the LC signal. And if you're listening before, I told you what the LC signal, it's a constant standard root. Ovariance versus sum versus matter versus technical S versus MT1. So that takes the 1E signal and it takes that root and then it trains the model basically to one mp3 file. And like, what does that do? It basically, cylindrifies like the signals. Now it's cross looping. It's taking that 0 but in a different direction. Like it's like a record player would. And it crosses a signal. So with the other signal, with the arrays, functions, and device, like with a one mp1 to one mpg file, right, or one mp2 to one mp3 file, it takes that 1E signal, crosses the jam, point 1E to point 30.org, right, the organization signal, or the 1E signal, or the 1IE signal, or there's multiple ways, or the constant consideration, the file that plays the constant file. That's the 101 signal or 0011 signal, the constant in array, basically the function of the fat cat, the system signal that signifies the array versus function. And that one MPG file now takes that array, that function, and it plays it into one MPG file, basically. What does that do? That takes that 1E signal and it turns that array into a function that devises, 1P signals, or again, and it takes that array, that function, and it circulates the system into a 1PE signal once again. That plays that array, that function, that flow, that one MPD file, and it takes that array function and it flows the output into an array function and a one MPG file again. So that's now an